Okay, in this curve we have a y equals to 2x squared plus 3x minus 15 over x times x plus lambda. So from the equation, you could see that there are two asymptotes which are vertical, okay, and there's one horizontal asymptote. The vertical asymptote will be when x is equals to 0, okay, that's when the denominator gives a value of 0, or x is equals to negative lambda, that will also give the denominator 0. So these are the two vertical asymptotes. As for the horizontal asymptote, alright, we notice that the power of x squared is for the numerator as well as for the denominator. And if that's the case, we simply take 2, y equals to 2 over 1. And therefore y equals to 2 is the horizontal asymptote. There will be no oblique asymptotes because the power of x squared is the same in the numerator and denominator. Next, we want to find the turning point, so we need to find dy over dx. Okay, so this is the expression. We equate it to 0 to find the turning points. Simplifying it, we get 2 lambda x squared minus 3x squared plus 30x minus plus 15 lambda equals to 0. Okay, the reason why I do that is because later we're going to sub in different values of lambda. So this is a general equation. So the first part, when lambda equals to 2, we substitute in. We find that x is actually equals to negative 1.036 or negative 28.96. And the corresponding values of y will be 15.98 and 2.02 respectively, corrected to 2 decimal places. So to sketch a curve, let's find out what happens when x tends to negative 2 on the negative side as well as the positive side. Because we've already identified the asymptotes, the vertical asymptotes. So correspondingly, y is negative infinity and y equals to positive infinity for negative 2 on the positive side. We do the same thing for 0 to negative and 0 tending the positive side. And this is what we get. We also like to find the intersection of the x-axis, so we substitute y equals to 0 and we get two values of x, which are 2.089 or when x is equals to negative 3.589. Now, y equals to 2 is an asymptote, so I want to find out how does the point intersect at which x coordinate, and correspondingly I get x is equals to negative 15. So that means the curve actually passes the horizontal asymptote, which is very normal, before tending to y equals to 2. Next, to show that when x tends to negative infinity, alright, we see that both the values of y tends to 2. As in, when x tends to negative infinity or positive infinity, both the y values tends to 2. And so this is a sketch when lambda equals 2. We notice that there is a portion in the middle here, and these are the two sides. Okay, next part, when lambda is equals to 4, okay, we find dy dx equals to 0. However, in this case, we find that there's no solution of x. Okay, therefore there are no turning points first. Next, we do the same thing and find out what happens when the curve tends towards the asymptotes, the vertical asymptotes, and these are the corresponding values of y. And also when y equals to 0, x are the corresponding values as above when lambda equals to 2. So this is the sketch of when lambda equals to 4. Okay, when x tends to negative 4 on the negative side, it is positive infinity, and it tends to y equals to 2. When x is between negative 4 and 0, okay, we notice that it actually takes a value in this form. And when x tends to infinity, when it's bigger than 0, okay, this is the part of the curve. And finally, when y equals to x squared and lambda equals to 4, this is for the last part, because we're asked to solve for this, that equation. we find that we need to find the curve y equals x squared so that we could find the solutions for this equation. It's power 4 plus 4x cubed minus 2x squared minus 3x plus 15 equals to 0. So as you can see from the curve itself, it intersects the original curve at 2 points here and here. Therefore, y equals x squared cuts a graph in part 3 at exactly 2 points, and so there are only 2 solutions as shown. Thank you.